Okay, folks, these are the video answers for the Gravitron ride problem set. So we have a person on the ride, and let's go through the forces first. Draw a force diagram. They are being pulled towards the Earth. They are touching a surface, so the surface is pushing back with a normal force, and they would slide down the wall, so they catch on the nooks and crannies, and there's a force of friction straight up. This is the circle that they're going in, and you can see that the normal is pointing to the center of the circle. So friction and weight are perpendicular to the circle. They're going to go in our non-radial column, and in must win, the normal is pushing them in. Okay, so A, we drew the force diagram. B, what is the radius in order for them to not slide? Okay, not sliding means in the non-radial column, the forces are balanced. So usually it's normal balancing the weight, and it's a boring problem. Right here, the nooks and crannies are catching, and it's a boring problem. So friction equals mg. We can calculate mg because that's 75 times 9.8, or 735 newtons. And then we want them to, that's friction, but radius you can see isn't anywhere here. Where does radius come in? In the radial column. It is sum of the forces equals mv squared over r. You have to have an inward force. You don't have to have an outward force. So in this case, the normal force equals 75 times 9.5 squared over r. And r is what we're looking for. So it looks like we don't have enough to solve it. It's like I don't know the normal, I don't know r, but there's a, I won't say hidden, but there's another thing we haven't used, and the connection between friction and the normal is fun. So kind of running out of space here, but F equals mu n. You can put that in your miscellaneous column. We know what friction is. Friction is 735. Mu is 0.16 times the normal. So this 735 newtons of friction, because they're not sliding, is equal to mu times the normal, and that means the normal is 735 over 16.16, which is 4,593 newtons. So that's how much I have to be pushed into the wall in order for the nooks and crannies to catch enough in order to balance the weight. Okay, so now we can take this equation, and now we know what the normal is. So 4,593 equals, I'm going to do that math right now, 75 times 9.5 squared, 6769 over r. All right, then I'm going to cross multiply and get 4593r equals 6769. And then I'm going to divide both sides by 4593. And you get a radius of 6769 divided by 4593 equals 1.47 meters. Okay, let me make sure that that makes sense. Yep. Okay, so there's a lot going on, but trust me that the force diagram is always going to look the same. In your non-radial column, the forces are balanced. In the radial column, the normal force, just like the racquetball and the hula hoop demo, it's the normal force causing the turning. And the connection between the radial and non-radial column is your miscellaneous friction column. So it's just a matter of putting all of those three columns together, depending on what you know and what you don't know. Okay, awesome. I will delete this stuff. Okay, question 2. Gravitron ride has a radius of 2.8 meters. Coefficient of friction is 0.208, and we know how much mass they have. Question number A, how much friction do you need to make sure they don't slide down the wall? All right, so that's going to be in our non-radial column. Not sliding means the forces are balanced. And friction is up, so that's positive, minus the weight. And those are balanced. And we're looking for friction, so friction equals the weight, which is 74 times 9.8, 725 newtons. Okay, so we need 725 newtons of force for the person to not slide. Calculate the minimal tangential speed. Okay, so speed comes into the radial column because in minus out, in this case, normal is the only inward force, equals mv squared over r, and that's your speed. That's where that's going to come in. Okay, so the normal force equals 74 times, we don't know, v squared over r, and r is 2.8 meters. So again, it looks like we don't have enough to solve this because it looks like we have two unknowns here. And why the heck did I find friction? But what we haven't used is that coefficient of friction. So in our miscellaneous column, friction equals mu times the normal force. And we know we need 725 newtons of friction. We know that mu is 0.208. And we know the normal force is this combination. I'm going to do 74 divided by 2.8 is 26.43 v squared. So I just combine these two things, 26.43. Okay, and now we have everything but v squared. So let's do a little bit more math. I'm going to take 0.208 times the 26.43. So this is 5.5, basically. V squared, divide by 5.5, divide by 5.5, and you get v squared equals 132. Take the square root, 11.5 meters per second. Okay, let me just check that. Yay. Okay, so again, this is tricky because you're going to have non-radial, radial, and miscellaneous, and you're going to have to combine the stuff that you know in order to solve for what you don't know. Okay, the final question is, again, same force diagram. Oh, nope, sorry, we didn't do 2B, convert to revolutions per minute. Okay, we need to convert from regular speed to figure out how fast it's rotating. So we have 11.5 meters per second. And we want to go from seconds to minutes, so 60 seconds equals 1 minute. And the seconds will cancel. And then we need to go from meters to revolutions, and that's what's tricky, is that 1 revolution is 1 circumference, or 2 pi times 2.8 meters. So that equals, multiply everything in your numerator, which is 689 revolutions, divided by everything in your denominator, which is 17.6, and then the units left are minutes. So 689 divided by the 17.6 gives you 39.2 revolutions per minute, or RPMs. All right, final problem. Question A says, what is the source of the centripetal force? I'm not quite sure what they mean by the source, but basically what causes the person to turn is the normal force. And the source of that is the fact that the wall is being compressed and the wall pushes back. Okay, so basically the normal. Question B, what is the normal for the 55 kilogram rider? So since the normal is in the plane of the circle that the rider is going in, that's going to be in our radial column. And we're going to say in minus out equals mv squared over r. The normal force is in equals, let's see, m is 55 kilograms, v is 10. And sorry, that's a sloppy 10 squared, and the radius is 3.3 meters. So 55 times 100 divided by 3.3 is 1,667 newtons. And then C is how much friction do we must we have in order for the person to not slide. Okay, so that's in our non-radial column. And the forces are balanced. So that means the friction going up minus the weight going down has to balance. So friction equals the weight, which is 55 times 9.8, or 539 newtons. But we have to do our miscellaneous, because what we want to know is what is the coefficient of friction. So we're going to use the fun formula that the friction that we need is 539 newtons. We're looking for mu, and the normal force is 1667. So mu is going to be 539 over the 1667, or 0.323. And mu does not have units. All right. That is the end of the Gravitron ride problem set. Again, the force diagram is always going to be the same, but you will need your radial, your non-radial, and your miscellaneous column.